Hi friends. Welcome to the YouTube channel DM Info Videos. We are here today with an interesting new video to enlighten the viewers. Continue watching this video till the end so that anybody will come to know about the much unfamiliar information and wait eagerly for the episodes to publish regularly. Please like and comment, share, subscribe and tap the bell icon for receiving the notifications on the upcoming videos. Trust that everyone must have watched the previous videos that were published. If not, please click the links given below to know them and share. Episode 11. In this episode, we will learn about renewable energy materials, forms, and researches. It will speak in this video with an introduction, revealing history, main natural energy sources, emerging technologies, usage in developed and developing countries, cost forecasting, environmental impacts, and future needs. Introduction. Non-renewable sources of energy include fossil fuels such as oil, gas, and coal, which are limited and consumed fast after the rapid increase in the human population. Moreover, these sources take a long time to replenish according to the behavior of nature. Non-renewable energy sources are available in selected countries only, while sun and wind have access in all the places of the earth. Fossil fuels also pollute the atmosphere, wherever they are produced and used, thereby create harmful health hazards to the living beings of the world. On the contrary, renewable energy sources are much cleaner than fossil fuels. Renewable energy is either generated directly from natural sources or produced through constant replenishments on a human timescale. There are many carbon-neutral sources like sunlight, wind, water, tidal waves, and geothermal heat. Revealing history much earlier to coal as a fuel for producing energy, renewable sources like water, wind, animals, human labor, and traditional biomass called firewood were used by humankind. Wind energy is used to direct ships on the water. It can be traced back to 7,000 years ago, the movement of ships in the Persian Gulf, the Nile River. Geothermal energy for taking baths in hot springs during the Paleolithic era and surface heating was used in the ancient Roman periods. Main sources of renewable energy. Solar energy. It is divided into passive solar energy and active solar energy, depending on how they capture, convert, and distribute. Passive solar techniques include orienting a building according to the movement of the sun, selecting materials with favorable thermal mass, the reflection of light, designing spaces that naturally circulate air. On a smaller scale, passive solar homes are designed to receive the sunlight through south-facing windows and then retain the warmth through concrete, bricks, tiles, and other materials that store heat. Some solar-powered homes generate more than the required electricity, allowing the homeowner to sell excess power back to the grid. Active solar techniques surround thermal energy, either by directly converting sunlight into electricity using photovoltaics, PV, or indirectly getting concentrated solar power, CSP, by using collectors to get heat and energy. The photovoltaic, PV, system converts light into direct current, DC, by taking advantage of the photoelectric effect. The concentrated solar power, CSP, system uses lenses or mirrors and tracks to focus a large area of sunlight into a small beam. Concentrated solar power plants developed commercially in the 1980s. Kenya is leading in the per capita installations of solar power systems. More than 30,000 tiny solar panels, each producing 12 to 30 watts, are sold in Kenya annually. Preparing outdoor food with solar cookers using sunlight as an energy source is on the increase. Solar PV is a multi-billion, fast-growing industry, continues to improve its cost-effectiveness, and has the most potential with CSP than any other renewable technology. CSP Sterling has by far the highest efficiency among all solar energy technologies. Wind energy. The speedy wind is used to run the wind turbines installed in most offshore areas. Modern utility-scale wind turbines range from 600 kilowatts to 9 megawatts. With the increasing wind speed, power is generated to the maximum capacity of a turbine. Wind farms are formed at places where the wind speed is great and constant, such as offshore and high-altitude sites. It is a leading source of energy in Europe, the US and Canada, and the second largest in China. Denmark gets more than 40% of its electricity with wind energy, while Ireland, Portugal and Spain each get nearly 20%. Hydropower energy water either in a slowly flowing stream, river or in a moderately swelling sea. The ocean can yield considerable energy. The below projects carried out by adopting this concept. A large amount of hydropower is generated by constructing huge dams and reservoirs in developing countries. The largest of them is the Three Gorges Dam, 2003, in China, and the Itaipu Dam, 1984, built by Brazil, and Paraguay, Guri Dam in Venezuela. Small hydropower installations typically produce up to 50 megawatts of power. They are often used on small rivers or as a low-impact development on larger rivers. China is the largest producer of hydroelectricity in the world and has more than 45,000 small hydro installations. River runoff hydroelectricity plants derive energy from rivers without the creation of a large reservoir. The flow of water a stream, a river from the ridge of a hill, if diverted through a penstock to the valley, can rotate a turbine for tapping electricity. Hydropower is produced in 150 countries. More than 50% of renewable energy is generated through the hydroelectric process by developing countries. China is the largest hydroelectricity producer, with 721 terawatt production, representing around 17% of domestic use of electricity. Energy in the Ocean's Wave Energy project uses the ocean waves on the surface, and tidal energy converts the energy of tides in the ocean. A demo project operated by the Ocean Renewable Power Company on the coast of Maine, and connected to the grid, harnessed tidal power from the Bay of Fundy, a location with the highest waves and tides. Ocean thermal energy conversion is done while using the difference in the cool temperature in the deepest portion of an ocean and the warm temperature on the top surface. It has a big generation of energy as the difference in temperature is very high. But at present, this conversion has no feasibility on the economic front. Since advantages are global and having future potential, investing more money to study the feasible, economical methodologies would be ideal and fetch good results in the long run. Geothermal energy. It is an energy similar to ocean thermal energy, as explained. Geothermal heating, for example, using water from hot springs, has been used for bathing since Paleolithic times and space heating since ancient Roman times. However, more recently, geothermal power, the term used for electricity generation from geothermal energy, has gained importance. Our planet is the part of the Sun which detached from it millions of years ago. This fireball cooled down slowly and thus the formation of Earth and has the energy inside a thermal form. The temperature of the Earth's core is nearly 4,000 miles below the surface, maybe over 9,000 degrees Fahrenheit or 5,000 degrees Celsius. Heat conducts from the core to the surrounding rock. Extremely high temperature and pressure cause some rock to melt, which is commonly known as magma. Magma convects upward since it is lighter than solid rock. Geothermal power is electrical power generated from geothermal energy. Technologies in use include dry steam power stations, flash steam power stations and binary cycle power stations. Geothermal electricity generation is currently used in 26 countries, while geothermal heating is used in 70 countries. Geothermal power is considered a sustainable, renewable energy source because the heat extraction is small compared with the Earth's heat content. The greenhouse gas emissions of geothermal electric stations are on average 45 grams of carbon dioxide per kilowatt-hour of electricity, or less than 5% of conventional coal-fired plants. As a result of government-assisted research and industry experience, the cost of generating geothermal power decreased by 25% over the 1980s and 1990s. More recent technological advances have dramatically reduced costs and thereby expanded the range and size of the viable resource in the year 2021. The U.S. Department of Energy estimates that geothermal energy from a power plant, built today, costs about $0.05 per kilowatt-hour. Bioenergy. Biomass is biological material derived from living beings or recently living organisms. As an energy source, biomass can either be used directly via combustion to produce heat or indirectly after converting it to various forms of biofuel. Conversion of biomass to biofuel is done in different methods broadly classified as thermal, chemical, and biochemical methods. Wood remains the largest biomass energy source today. Include forest residues such as dead trees, branches and tree stumps, yard clippings, wood chips and even municipal solid waste. Biomass converted to other usable forms of energy such as methane gas or transportation fuels such as ethanol and biodiesel. Rotten garbage and agricultural and human waste release methane gas, also called landfill gas or biogas. Crops, such as corn and sugarcane, can be fermented to produce the transportation fuel, ethanol. Biodiesel, another transportation fuel, can be produced from leftover food products such as vegetable oils and animal fats. Biomass, biogas and biofuels are burned to produce heat, power and harm the environment. Pollutants such as sulfurous oxides, SOx, nitrous oxides, NOx, and particulate matter, PM, produced from the combustion of biomass. World Health Organization estimates that 7 million premature deaths are caused each year by air pollution. Biomass combustion is a major contributor. Emerging technologies. Other renewable energy technologies are still under development and include cellulosic ethanol, hot dry rock geothermal power, and marine energy. Cellulosic ethanol with advanced technology is being developed. Cellulosic biomass, such as trees and grasses, are also used as feedstocks for ethanol production. Ethanol is used as a fuel for vehicles in its purest form and bioethanol in the United States and Brazil. Enhanced geothermal system. Enhanced geothermal resources to reach hot rock, HDR, through hydraulic fracturing. It is a new type of geothermal power technology that does not require natural convective hydrothermal resources. Geothermal energy within drilling reach is in dry and non-porous rock. Enhanced EGS and HDR technologies, such as hydrothermal geothermal, are expected to be base load resources that produce power 24 hours a day in a fossil plant. Good locations are over deep granite covered by a thick, 3 to 5 kilometers, layer of insulating sediments which slow heat loss. The HDR and EGS systems are currently being developed and tested in France, Australia, Japan, Germany, the United States, and Switzerland. The largest project of EGS is a 25 megawatt demonstration plant currently being developed in the Cooper Basin, Australia. The Cooper Basin has the potential to generate 5,000 to 10,000 megawatt. Marine or ocean energy. The movement of water in the oceans creates a vast store of kinetic energy. The term marine energy encompasses both wave power and tidal power obtained from the kinetic energy of large bodies of moving water. Reverse electrodialysis, RED, generates electricity by mixing fresh river water and salty sea water in large power cells designed for this purpose. The oceans have tremendous energy and the potential of providing a substantial amount of new renewable energy around the world. Nuclear energy. Nuclear is a zero-emission clean energy source. It generates power through fission, which is the process of splitting uranium atoms to produce energy. According to the Nuclear Energy Institute (NEI), the United States avoided more than 476 million metric tons of carbon dioxide emissions in 2019. Artificial photosynthesis. It uses techniques including nanotechnology to store solar electromagnetic energy in chemical bonds by splitting water to produce hydrogen and then using carbon dioxide to make methanol. Crop wastes. Aureus devices, Aurora Renewable Energy and UV sequestration. Based on crop waste, can absorb ultraviolet light from the sun and turn it into renewable energy. Microhydro. Microhydro configured into mini-grids also provide power. Over 44 million households use biogas made in household-scale digesters for lighting and cooking. Alcoholic fuels. Non-food sugary, starchy, and cellulosic feedstocks sustainably produce ethanol and methanol. Project Gaia, Inc. and Clean Star Mozambique implement clean cooking programs with liquid ethanol stoves in Ethiopia, Kenya, Nigeria and Mozambique. Water vapor. The collection of static electricity charges from water droplets on metal surfaces is an experimental technology that would be especially useful in low-income countries with a relative air humidity of over 60%. Renewable energy in developed and developing countries. Developed countries. 2 countries, Iceland and Norway, generate all their electricity using renewable energy already. 47 nations in the world have over 50% of electricity from renewable resources. 30 nations worldwide already have renewable energy contributing more than 20% of their energy demand. Developing countries. The energy requirement is more crucial for humans in developing countries than the developed ones. Large-scale renewable energy projects are available only in developed countries. Renewable energy sources can better suit rural and remote populations, as fossil fuel energy's transport and distribution process are difficult and expensive. Local production of renewable energy is a viable alternative. The energy projects can source small businesses and employment and eliminate poverty. Most renewable energy technologies provide electricity, which has several benefits. Electricity can be converted to heat, mechanical energy with high efficiency, clean at the point of consumption. Cost forecasting. Even if a sustainable source of energy costs more, it may be cheaper in the long run. Climate change and global warming concerns, coupled with the continuing fall in the costs of some renewable energy equipment, such as wind turbines and solar panels, are driving the increased use of renewables. Renewable energy sources are increasing to displace fossil fuels globally, as they emit low carbon and eliminate air pollution. According to the International Energy Agency (IEA), renewable energy is expected to fulfill nearly 30% of the world energy requirement by 2024. Lazard, the agency tracking energy prices for many years, pointed out that wind power prices dropped by 71% in the year 2020 compared to the year 2009. Solar energy became cheaper by 90%. For example, energy from new wind turbines and solar panels are now cheaper than coal and gas plants. Solar power costs half as much as lighting with kerosene. Renewable energy projects are either given subsidy or concession by the government in tax holidays, on-account payments, partial investments on land and machinery to encourage entrepreneurs. It also indirectly enables the people in getting the energy cheaper. Environmental impact. The contribution of biomass and biofuels to reduce carbon dioxide emissions is limited. Wind power, solar power, and hydroelectricity have the advantage over biomass and biofuels in conserving water, less pollution and reduce carbon dioxide emissions. At the same time, about 2,000 renewable energy facilities were built, and more progress in the areas of important environment and threaten the habitats of plant and animal species across the globe. It should ensure that renewable energy facilities are built in places where they do not damage biodiversity. Renewable energy devices depend on non-renewable resources such as mined metals. Solar panels change the albedo of the surface, what increases their contribution to global warming. Mining materials for renewable energy is likely to increase the threats to biodiversity. Future needs. Emerging technologies are not yet widely demonstrated or have limited commercialization. Many organizations in the academic, federal, and commercial sectors conduct large-scale advanced research in renewable energy. Each aims to improve efficiency and increase overall energy yields. Thank you, viewers, for sparing your valuable time and watching renewable energy on this YouTube channel. DM Info Videos. It must have enhanced the understanding of civil engineering, placed everyone in a new light of exposure, and inspired us to learn more. Else, online technology helps us repeatedly viewing to get the benefit. Would you mind waiting for the next video to publish early and keep watching the videos regularly published on this channel? Would you please share and subscribe for more fabulous inspiration? Thanks again and wishes to prosper ever.